All right, ladies and gentlemen, welcome back to another video with Mr. Kenton for AP Chemistry. And we are moving along in Unit 3. We're actually about to get to some practical applications, some experiments that you can take a look at that can put into practice some of the things that we've been looking at. And so in section 3.9, we're going to be looking at the separation of solutions and mixtures. There are different ways to do that, but then we're also going to focus in on one that you might not be as familiar with, which is called chromatography. Now, topic 3.9 can be found in section 1.3 in the textbook under the separation of mixtures on pages 11 and 12 only. So be sure to check those out, read over that, and take a look at that as you're preparing and looking at these things. And so, you know, when we think about from chemistry from a perspective, a lot of this is going to be lab-based, and certainly this particular next couple sections are going to have a lot of lab-based components to them. And so just kind of be mentally prepared for that as we're talking through certain laboratory procedures. Okay. Now, the first thing that we need to recognize is that mixtures, like we talked about when we were talking about classification of matter, mixtures are physical combinations. So that means that we should be able to do some sort of process to separate out the different components that make up our mixture, whether they're homogeneous or whether they're heterogeneous, right? And so one thing that we can do is filtration, right? Or I think you've also seen it, the term gravimetric analysis, right? And so filtration is simply you've got a liquid and you probably had two aqueous solutions, you mixed them and a precipitate, a solid was formed. And so now your goal is, I want to get the solid. I want to figure out how much of the solid I produced. And so filtration is an excellent technique for separating solids that are produced when solutions are mixed, right? And so you have a setup where you have something like a ring clamp, you have a beaker, you have a funnel, and then within the funnel you have filter paper, which allows for the water to move through it, but then the filter paper captures the solid, right? You would do this process, you'd pour the liquid through, you'd eventually get all the solid, you'd want to rinse it off, then you'd want to heat it to make sure you removed all the water, and then you could determine how much of the solid was produced through that particular chemical process. The second way we can separate mixtures is if we're dealing with mixtures that contain two liquids, which is the distillation process. Right, and we'll talk more about distillation here in a little bit. And then the third process, which I would imagine you may or may not be as familiar with, is known as chromatography, right? And so chromatography is when you're separating two different components based on their differences in their intermolecular forces between the mobile phase and the stationary phase. So typically it's the liquid that moves up the filter paper being the stationary phase. The liquid that's in the bottom of that beaker there would be the mobile phase. So we've talked about filtration. Let's spend some time looking at distillation, right? Now, distillation is a process that takes into account that different substances can have different boiling points. Specifically here, we're talking about probably two different liquids, right? And so what we can do is we can separate a mixture by adding heat to boil one substance off, but leave the other behind. And so, you know, as you're doing this, say, like you're looking at the setup that you see on the left and even kind of the more realistic setup that's on the right, you've got a solution that's in a flask. And you've got it set up on a hot plate or a Bunsen burner, and you're heating that solution. And so what's going to happen is as the substance that has the lower boiling point is heated, it's going to be converted into that gas phase first, right? So then that gas is going to move through the condenser, which is over here, right? And what will happen, that gas is going to pass through, it moves through the condenser, the temperature is going to decrease on that gas, and as it passes through the condenser, it goes back to a liquid and it's going to fall into the second container, and that's going to be your distillate, right? And so once you do that, you heat off all of the substance, you get all of it removed, you've then separated your two substances that were combined in your mixture, right? So I definitely see distillation as a process that's much more useful when you've got two different liquids that have been mixed together. Certainly It's not the only situation in which that works, but certainly that's something that you can do. Is you've got a mixture of two liquids that have formed a solution. Then you go through, you heat up one of them evaporates or boils out, and then you condense it back to the liquid phase and then capture it in a new container, right? So that's the distillation process. So distillation typically deals with two liquids. In your filtration, you're separating, when you mix two aqueous solutions, you get a precipitate, so you're separating a solid from a liquid, right? Which leads us into our last technique, which is chromatography. And chromatography is a technique for separating and identifying components within a mixture, right? And the way chromatography works is it plays on the intermolecular forces that are going to be formed between whatever the substance is that you're testing. You're going to have the mobile phase. That's going to be the substance that is moving within your paper, right? And so, like, for example, you're looking at this beaker. There's a liquid that's sitting here. This liquid would serve as the mobile phase, and then the paper would serve as the stationary phase. And so different substances are going to have different affinities. Some substances are going to be more like the mobile phase, and so they're going to move with the mobile phase. Some substances are going to be more like the stationary phase, and so they're going to move a smaller distance within that stationary phase as a whole, right? And so paper chromatography, what it does is it does things based off of solubility, right? And we can quickly measure the intermolecular forces of attraction to explain why a specific thing that was separated moved a certain distance, right? And so what you can do is you can take a look at it, and you can take a look at from the origin to the things that have been separated, right? You can measure that distance and then measure how far the solvent traveled. You can use what's called the retention factor, or RF, which would be the distance moved by, let's say, your particular component divided by the distance that's moved by the solvent. That would give you your retention factor, which would tell you how far that particular component traveled, right? And so chromatography is a useful tool. It can be used in the context of biochemistry, like in terms of separating out different amino acids. And so you could also use it to separate out different components of like dyes or pigments within like pens and things like that. And so again, it's another technique that we can use to separate out mixtures, taking advantage of their different intermolecular forces of attraction, right? And so, like we said, we've got filtration, separating out solids and liquids. We've got distillation, which is typically used to separate out two liquids that have been combined. And then for chromatography, depending on the context, you're simply taking a sample and you're separating out based on differences in intermolecular forces, right? And so each of those are techniques that you need to be familiar with, understanding how they work. And I'm hoping, ladies and gentlemen, that we can find you guys some sort of example where you can maybe do a chromatography virtual experiment or something like that. I'm in the process of looking for something, so kind of be on the lookout for that. Well, that's going to conclude this particular video. Thank you guys for joining in. If you do have any questions, feel free to reach out, fill out the Google form, put your questions there, or ask a question during class. Thank you guys, and I look forward to seeing you guys again soon.